meeting room 3. Okay, so you given the integers and there are some rooms and you given the early meetings starting. So have codes. Okay, so end time or the values start are unique. Okay, so what it means? Start when unique said. Meeting are allocated to room environment managers. Each meeting takes place in a use room with the lowest number. What it means? Oh, it's okay. We have n rooms here, and what we do is that return numbers of a room that held the most meeting. If there are multiple rooms, return a room is lowest. What it means? Okay, so if there is a available room, will delay until room be free. Delay meeting should have the same durations as the original meeting. When a room becomes unused, meeting with earlier original start time should be given. Okay, so start time is in increase. So is it increasing? Okay. So at time 0, both rooms are not used. And then the first room start run 0 out time 1 or 1 was going to be used. And start time was delayed. Both rooms are being used. The start is delayed, and the meeting one says the fourth meeting. Oh, so the meeting will be delayed, but the delayed meeting should have the same durations. Alright, so I know it. Suppose okay, so return number of the room. Held most meetings here. Right, so okay, and we can use its so we can use the count because n is more. We can use the count and return the next element. Okay, that's the answer. And what is the idea? We may start the meeting, and then we may start the meeting, and while students enter, only one not be used. Second room start in room 1. Both rooms are used. Third meeting is delayed. Delay until the time 5. The meeting in room 1 is finished. So third room will start it. Okay, so duration still be 5, right? So okay, so Okay, so what do you interesting is that we resort it and then we occupy the value. We just occupy len and we have see. Okay, I can do this problem later, so start in 5 minutes. Right, just the simplest problem. Here's a string lowercase where each letter appear exactly twice. You also given a zero index distance that's 26. In a wheel space string, the numbers later between two occurrence of distance. Wheel space, okay. I later distant I. If the I later does not appear, the distance can be ignored. A wheel space dimension B is straight, so 1 and 5 satisfy the distance 1, and the distance 3 is 5, but distance 2 is 0. Okay, so we can record the index here. Check the distance. Check the later distance. It's same as given. Right, so idea is for each later, we just check that in the A. We just record index here. Distance if index is empty, right, so else is index has size certain. Oops. So not equal to the distance, will return false. Okay. Distance is not empty. Wait. Let's try to think for each letter. Check the distance. Actually, here we say this one. Zero if size return false. Oh, okay. What's the idea? Right, so what it means? This is not empty. B is 3. B is correct. And D. Oh. Okay, D is 5. It can be ignored. Okay. I know that. So okay, I misunderstand the problem because if we don't need, it's empty. We don't do anything here. And we'll check that if okay, a little ugly here. Last things doesn't matter. Alright, so numbers of way of reach position. Exactly, K-steps. You are given two positive indicators, start position and position. You're standing on the start position on infinity line. One state, you can either move it one to left, one position to the right. Starting position. Exactly, okay, stay here. 2 is difference, not the same. Right, there is that DP here. Where's the number of way, reach, and position? Use K-steps. Right, there is DP. We can use the transition is that we have current is the X and we use the state. Right, so if used, if X is and position, return used should be equal to K if used is greater than K, or X is more than 0. We don't have any numbers of ways here. And the value is big. Standard programming, we have dp and x and numbers of state. We can either going to the left, going to the right. So okay, x minus 1 is 1. Okay, add minus 1. Right, left, 1. And now we should use as a dp memo. This is memo. Alright, so dp, we have rest state and DFS starting from start position. The state we use is 0. Alright, that's it. Use exactly one step here. Going to be 0. Smaller than 0, we should return false. Or well, we can make a negative 1, right? So I want to use older map because is dp, we use this state find it is dp use find x as it is not equal to used and x is equal to, so memo, it's memo. Okay. Why? Wait, I need to see. What's 1, 2, 3, 2. Starting from start position, we can minus 1. 1, 2, 3. You can going to be 1 and currency is 0, and next we can going to do 2, 1. Zero, 1, 1, 2, 2, 3. So we got a 2, 3 here. Zero, 3 here, and 0, 3. Got 2, 3. Also got 2, 3 here, and two, 3. I got this is going to be 2, 3. You should be 3 and 2. 3 and 2. You can get 3. We can still be right, so return x and position. That's idea. We can, the base case is wrong, right? So the base case is wrong. Overall time complexity is the n squared. Right, so why? Right, it's too slow. We can use is that we start position is 1 and then starting from the end, so end position 3 is going to be now we still have this 2 is going to be 1. We updated as right, it's too small, too slow. Okay, so we can use. Alright, I want to use not download the set. Instead we use is that instead we use by the we ship by 1000, so we can use a little type here. Alright, so longest nice subarray. Given the numbers consist of positive integers, a subarray is nice, bitwise and the repair elements different position. The subarray is equal to 0. It's nice. Bitwise end is 0. Okay. Longest nice subarray. Alright, so longest nice subarray. Nice is as pairwise and are or 0. So what kind of idea, this is a nice subarray. Every pairs are difference is equal to 0. Means that they cannot have common digit. We cannot have common digit, so longest subarray is because it's distinct. Alright, so it's digit. Should be distinct. They cannot have common digit here. So actually, a subarray. That means a subarray can have common digit. Alright, so cannot have common digit. So that is nice. It's nice. Right, so this is nice subarray? No, because we have common digit here. I want to use sliding window. When you add, we can add the bit. It's going to be 22. So for when you add a number, sliding window say because if the window is nice, that all the subarray is always be nice. So we can have a window here. Now well, not nice. as numbers are. What is code add? It's given an integer, not nice. If bit I is equal to 2. And at the rate, say, bit I add about x. And remove, save this. Okay, so that's the idea. Oh, number is very big. Okay. I misunderstand the misunderstanding. Oh, get it out of the penalty here. So for each time step, idea is go through the time step. Go through the time step and then and then when we are meet at our start position, it means that we can add so we are going to queue. We're still going to the queue. So we're going to the time step here. First, we don't sort it because the order doesn't matter, so we sort it. Ideas that sort the meeting by start time. It goes through the time state, and then while the time state, or we don't go through the time state, we're just going to be, it's like we can use time step. Actually, we cannot use the time step because the time step is very big. So maybe TLE here. So what else? We should go through the start procedure. Okay, so okay, so interesting problem. Low list unused room 0. But I'm stuck about how do we go through the meetings here, because if we start in alright, so we use a spots. For example, the meeting or time state. If the time state, your current time state, it's 0, enter 0, and then when we enter new, so our problem is really interesting. When we have a meeting room, we may add very separated. Start is unique. Start meeting room is unique. So we are saying that is so that must be simulate the meeting. So in this example, when we current time 0, we enter the time 0 here, and now we ending at the 10 because they still have occupied. So we use the ending. Now we should record it. It's that the end time will has a 0 here. So now time is greater than time state. Okay, let's think. Go through the time space. Current time is 0. We enter the room 0 and current 1. Start on Leetcode. The time let me think. I have some idea, but step by step is still. How do we jump over the time step? Is all how I stuck in this problem. If we know we can faster jump the date, so if actually after maximum time, after maximum start time, all the value in this tree, all these guys are entering the room, right? And we should use the starting time should be given. The lowest earlier original start time should be used, so we can enter all the guys in this. And we try to do is that storage noise greater, so we put in these guys here, and 1 5 we are going to do let's talk about how to implement efficiently. Both runs are not being used. First meeting run starting run 0. Run 1 is not being used. Second run starting in run 1. Run 3, both run 3 being used. The third meeting is delayed. So when we enter all the meetings here, we are trying to do is that we still have a queue, and we have if we use it, and then when you enter to the next start time here, if okay, alright, I may think another idea is go through the meetings, because our meetings should always belongs to any run, right? So starting from the meeting run 0 here, and we occupy the run 0 because we occupy run 0. Right, so we still have the run, we still have the end time of each run. Time of each run. So when we started, we go through the meeting, and then we are trying to use the smallest end time here. Okay, I want to use priority queue. Summing heap, storing end time and run ID. And currently we have all runs are writable, so we still record end time, right? And now it's a variable, right? So if PQ hard it's first, because we always use the smallest time, right? So sleep is smaller, means that smaller than the start time. Smaller than the start time. And so go through the meeting, just simulate it. first advice that goes your meeting simulated because all the meeting will occupy one room. Right, so in this step, we use the first saying that we always choose the n time, the I. We always use this room here. We always use this because so let's say PQ will push the current duration instead the end time. So the next duration is going to be 10, right? So 10. Still be I. Use iron. Low is the so and then is the room in time is smaller. Start time. That means for example, if this is smaller, this is greater. We have delay, right? So we have delay. Wait, I don't think. For example, 0, 10, 1, 5. We enter in the room, and then none of these guys here is 2, and we are part of these guys. We are part of the room 5 here because stake and run is starting in room 1. So we start in starting. Priority queue. We use one. Okay. That's the idea. Why? Right, so when we have this end time, we must use this root because this is the smallest end time here. And then in the next example, exact 0, we used I. Why? Because the first room we are going to use 0. We use 1, we use 2, we use right, so say for see our count. Oh, so smallest run ID should use why we use 2. Oh, so I know that in the current time state, it's that. Oh, okay, noted. Not that simple, because we may have a lot of n-time that is available, so okay, we'll push. And then we need to use Okay, I want to go to bathroom. Right, so wait a moment. If the one variable if we don't have a variable, we use the smallest n time. So we say this. Okay, so we use first smallest run, and then the n time we will push its That's it. Oh, okay, so I'll pick you top first. A little dirty, but wait. What? Wait. Why? This guy is this n, right? So 1 is going to be 20. Then they are still be available. They are still be available. So let me try to sync it. Okay, let's just Alright, so let's say this kind of right, let's just make shortland because we want to use smallest available run ID here, and we add run, and yeah, that's what's two meetings here. Start 302. Even one we never use 0. Why? Okay, so start as order. So, oh wait. Here we are saying that so what else? Let's just try around this, right? This case. Now this case is first we need to do is we are occupied the end time is going to be 0, and we add start time. So get it's 1, the end time going to be it's 21. So run, we have 3 rooms here. So now starting from run 0s, run 1 is not being used. Second run starting from run 1. Yeah, second run starting from run 1 here. So we used why we are using I. What we're using is 0, right? Why second run not 0? Because the end time it's greater, always be greater, right? So why? Oh wait, okay. ID is the second, is the first. Alright, just founding. Just founding. Use 0. Use run ID. It's end time. So OK structure is run ID end time. New end time is going to be still keep the same and keep the same. They are all reliable, right? So now what happens here is that we have pick size of the bag. Okay, it's empty. Push hard here. Right, so in the first case, we will use for run. Okay, size is 3, but should be 4 because why? It's just weird. Why is it 3? Available actually is why? First thing enters, we enter 0, we enter 1, we enter 2. Oh yes, 3 run. Yeah, it's exactly yes. Okay, so this guy is okay. Now it's we sorted, and then this guys we use to available, but where we use 0, we are enter 1, enter 2. And oh, okay, it's high. Alright, so that's it. Alright, so founding. Alright, so looks well. Do a lot of debug. Right, let's just see. Should be available. 0, 1, 0. Waste a lot of time. Right, so they may have runtime error here, so you need to care for this maximum. Right, this should be okay. Yes. Alright. Waste a lot of time. Stimulated, and then it's waste a lot of time here. Alright, wow, today's it's actually not hard, but I still waste a lot of time to doing this problem because still be earliest times. And actually we can optimize. We don't pop back this available because so we can use this if available. Can swap. Dump out, okay, 0 here. You can dump out, okay, 0 here. Still be okay. Let's see can be more faster. Okay, so because we don't actually, the okay will still be okay here, so waste a lot of time to debug. Actually, we can use priority queue. Still use another priority queue. Can be greater. We don't sort it. We don't need to sort it. Can make them still be in heap. Another optimization is still being heap here. Let's run ID. It's so that we don't sort it. So that's be neat. Okay, has to be more clean. Yeah, so to min heap and get it. So another optimization here. Yes. Okay, that's it. Alright, so alright, let's just go through the problem. Right. Okay, so why is this problem? It's I still waste a lot of time to do the first problem because I misunderstanding the problem statement. It's let's just quickly go through this 4 problems here. So actually you want to find out that the distance in the letters, the distance between the letters should equal to the distance that the function given. So for example, A's distance is 1, a number of distance between these two letters is 1, numbers distance between B is 3, A, C, C, numbers the letter in the C and C is 0. So satisfy this. 1, A is 1, B is 3, C is 0, but D is 5, right? But because we can ignore it, if we are not appearing the S, we can ignore it. So we just try to do is that for each letter, we check out the index. If the index is 0, we can ignore it. Otherwise, we just check that, okay, so if the distance should be equal to the, actually we can simplify to this guys here. Because O case is not be empty, so we can simplify to, can simplify the code structure to this. Because empty will continue, so we just check that if the distance is not equal, we return false. That's it. Simplify. And that's the problem 1. And about problem 2, you are given about, I waste a lot of time to optimize this dynamic programming. Actually, it's very simple. Like here's simple. You're just starting from a start position, and you can either going to the left and going to the right, and we just try to find out that what is numbers a different way to reach the position and the position. So for example, in the 1, 2, we can going to be going to 1 step to the right, going to 1 step to the right, going to 1 step to the left. So actually we can use a dynamic programming. The base case is that if the use is k, that means we just check that if the state is k, the end position is still should be here, should be the end position. The current position should be equal to end position. So and that's the idea. And I use a DP here. What is the runtime? Actually, it's TOE. TOE. Okay. So now let's get wow, 160 17 millisecond. So it's fast. So what is the idea? Because the start position and end position is small, so we can put in the DFS state and we just memorize them. But an important thing is that we use a integer to hash them. We shift the negative integer by 1000. So I shift the integer to 1000, and then so that to make sure that we subtract the value we cannot enter to the negative value, so we never be negative values here. So that's the idea. That's the idea. So this x is never be positive, never be positive, because we shift by 1000. So the logic step, we're going OK to the left, we will minus 1000. Case 1000, and x is 1. That will be x will be this, but if we should by add 1000, so the x is always be positive here. So yeah, that's the idea. And okay, I wasted a lot of time to do. And okay, this problem should not be one error. Is just stupid, because this problem is that you given a subarray, you want to find the longest nice subarray. And what is the nice? Nice is the bitwise and between every pair as a different position is equal to 0. So actually, this operation is satisfy also can convert to another condition is that we just check the numbers of digits that is cannot have the common digit. That's called nice. What it means? That means the bit set, for example, is 2 and 3. We also have convert into base 2. 2 and 3 is 1 1 1 0 1 1. They have the common digit here. So actually, the pairwise end is 0. Is actually we cannot have a common digit. Yeah, so we can convert to this condition. And observe this. Actually, another observation is that a window, we can use sliding window. Why? Because the window, if the window is satisfied if this is a nice subarray, that means that all the subarray in the window are always satisfied is nice. So we can use sliding window here. So it's an important observe. So let's just implement how do we move the window, how do we calculate the window is nice, and that's it. So we just sliding window here, we add a number, and while it's not nice, we remove, and otherwise we calculate maximum value. So that's the idea. Overall kind complexity is thinking so okay, and you can use sorting. Okay, sorting here. That's it. What is the type? Okay, still be fine. And about problem 6, problem 4, it's right. I think this problem is some kind of interesting problem and a classic problem. It's like you're given about a meeting room and you are trying to use the unused room with the lowest number, and the starting time that earlier should be go first. So yeah, And actually, each meeting room will always allocate to exactly 1 rooms here. So in this observation, we can go through some meeting, not go through a time state because the time space is very big. So yeah, okay, I hope you understand the problem. So now let's just go through some meeting and simulate it. First, we solve a meeting, and we need to calculate how many rooms are used. And I maintain a two mean heap. First is the mean heaps that maintain the end time earlier and the run ID. Another is the run ID first and the end time. And now we just dump them. If the end time is smaller, that means that we can push all of them to the OK. That is a valuable run. And we use, if they're empty, that means that we always use the smallest end time priority queue here. So now we always push it. And we can get it, the current end time and the current run ID. We just occupy this run. And we push into the queue to the next end time here. And OK is always be OK, so we don't push back the OK into the priority queue because the next starting time is always be the greater than the previous time. What it means? It means that the NJ0, it's always be smaller because satisfied. So we don't need to repeatedly pop out OK. Okay, so that's the idea. Overall time complexity is going to be space, and this is space complexity, and time complexity is going to be we have the meeting room, so it's meeting room product about here. That's it, and it's 100, so it's very small. So that's the idea. That's the idea. Okay. Alright, that's it. After we calculate it, we just return the maximum element. Yeah, so that's today's contest. Alright, so I have a lot of penalty here. Okay.